Hey, welcome to Zoo's workshop on the ML-Ephant Machine Learning API SDKs for Python. I know it's a mouthful. Today I'm going to show you how you can integrate our SDK into your own project. It's a very fast video, um, and it's to really show that you can go from zero to useful code um, very easily. We really care about developers first, and we hope that this video demonstrates that. So enjoy. Okay, let's go. API reference. We'll select Python. There's the pip install command for KittyCAD. We'll copy it with that little clipboard. We're going to create a folder for the project. Let's call it my ML project. Open that up. And then we'll create the first file, something like generate a model. Perfectly describes what we're doing. We'll open up a terminal. Here we will pip install KittyCAD. Quickly, we'll see that, VS Code wants to create a virtual environment for us for Python. So it does that. Click yes. It'll create it, and then it'll automatically run the pip command and install to a virtual environment so you do not clobber your packages. Let me go check out the ML endpoint to generate a CAD model. You can see the operation is performed asynchronously. That's the endpoint async operations ID. We're going to need that for later because some jobs take more time than a moment. We've copied the code to generate the model. Now we're going to make sure that we return, we're going to call the actual function in the first place. We're going to check the output. Oh, we're missing a Zoo API token. Let's go get a token. So we're going to go sign in. There's single sign-on. We're going to go with Google. In your account, you're going to go to Access Tokens. You're going to click on Generate an API token. Generates. You can copy the token. Copy to clipboard. Hop back there. Now you need to pass in the variable as a environment variable. Don't try to use this API token. It will not work. I have deleted this token. So don't try. So there we go. That's the output. We can see the job's been queued, and that's the job ID that we're going to need to pass into the async operation endpoint, which we're going to go check out right now. Hop back to the documentation, click on API, API calls, and then the async operations ID. Then we're going to go copy the Python code. In this case, we don't want to recopy some of the stuff we've already imported before, so we're just going to take that chunk that matters. Mostly the KittyCAD types. There we go. Those are the models. I'll come back. Let me copy the actual request, call, function. Paste that in there. Then we're going to make sure we actually return the body data, the result, because all of our documentation prints the results by default. We're going to allow this to take a prompt argument. Makes it a bit more parametric. We're going to accept KCL back, although it's not going to be used. That's our modeling language if you're unfamiliar. Here we're going to pass in a job ID. And then we'll type in a prompt. So we'll start simple. It's just a cube with the sides of a certain length. Then we will assign the result to a variable. And I'm just mentioning that this could return immediately because, again, if usually jobs are queued, but if you run the same prompt twice, it's cached. So you won't have to hit the async operations endpoint. And we're going to see now, I'm fast forwarding because this is just the polling code that I was talking about. And we just, if it does not, if it's not completed right away, then we keep on polling until it is. And we will wait 1 second between every single poll, because we don't want to just mash that endpoint, right? If anything, you would get rate limited. There we go. So there's the sleep. Now I'm just adding some commentary for when the program does run. I can see what's going on, if it actually is polling or if it immediately responds. So in that case, it was cached, as we can see. It only printed once. Or sorry, in progress. So this has, the jobs have 3 states. There's queued, there's in progress, and there is completed. In this case, I forgot, or I had a logic error. Once again, I forgot the API, the Zoo API token, because I'm entering the wrong command. This is a cached response because I literally just tried it right before. So we have to change it for the purpose of the demonstration, and we run it as final time, and we can see checking ML-Ephant operation, checking ML-Ephant operation. It checks it for a while, about 15, probably about 10 seconds, and there we go. That's it. Very straightforward. You can then use this GLTF data for a model viewer, or you can extract the step file. It's all really up to you what you do after that. Or you could take that prompt, or that KCL, sorry, the resulting KCL, and run it again over the prompt to edit. Cool. So with that, all that's left is to give you some tips and tricks that I've asked my coworker Greg, who works on the ML team, for. He says, keep your prompts very short, something between 1 and 2 sentences long. The longer the prompt is, the context just confuses the model. So avoid that. Really focus on like composing your prompts. I've personally had a lot of luck doing that. Don't ask for eccentric objects out of the model. We've trained our model on traditional mechanical parts such as like fasteners, bearings, connectors, gears. So ask it for those. Don't ask it for like a bear or a Christmas tree, because it's not going to do so well right now. In the future, it very well could. It's just that's not what we focused on in the short term. And lastly, if you ever see a 422 error code, it doesn't mean that the prompt was necessarily bad. It just means that the geometry that it tried to create was just invalid. So you can try that prompt again and again and again. It may eventually succeed. So just tweak the prompt a bit, play with the prompting within the Zoo Design Studio to also have some more experimentation. And yeah, so thanks for watching. We have some other videos on ML-Ephant and the KittyCat Design API, so go check those out, as well as KCL, our modeling language, and have a great day.